Hello everyone, welcome back. Let's go to 3.3 simultaneous equations on graph. So as we know, we could solve the two linear equations with elimination or substitution. Also, we could solve the equation, one is a linear equation, another is quadratic equations. But how do they mean on the graph? Okay, so let's look at example 4. So example 4, we have two equations. One is 2x plus 3y equals 8. Another one is 3x minus y equals 23. Of course, we can use elimination or substitution to solve the equations. We get the solution 1x and 1y. And then for the first equation, 2x plus 3y equals 8 is the linear line that we can draw on the coordinate system. Also, the second one, 3x minus y equals 23 is also a line. So we draw those two lines together on the same coordinate system graph. Okay, we have this. And then, since we already finished the two line, and we have one intersection point. This point is a solution we want to find. The coordinate of the intersection point is 7, -2. Alright, so let's look at example 5. So we have 2x plus y equals 3. Another equation is y equals x squared minus 3x plus 1. So the first one is a line, the second one is a parabola, so that we could draw the two curves on the same graph together. So we find out there are two intersection points. We find out one is -1, 5, another one is 2, -1. So we find out the two pairs of solutions. This is how we do to solve the problem with simultaneous equations by drawing the graphs. So if we have a linear equation, another one is a quadratic equation. There are three ways that's going to show on the graph. So first, intersect twice, like this, you could have 2 points. And second, intersect once, like this, you have only one intersection point. Or the last possibility is no intersection point. It's going to be like this. Okay, I'm going to clean that and draw again. So like this, there's no intersection point. So how to determine whether there are going to be 1 or 2 or 0 intersection points? We're going to use a discriminant again. This is what we learned in chapter 2. So how do we use this? Okay, so we have a linear equation and a quadratic equation. We could substitute y into the second equation with the quadratic equation, so that we have a quadratic equation left. So what does that mean? Let me show you. So if we have equation x plus y equals 1, another equation is yx squared plus 4x plus 1. So we could get y equals fx, then substitute into the second equation. So you have fx equals x squared plus 4x plus 1. So we can have a little bit. So x squared plus 4x plus 1 minus fx equals 0. So here we can use discriminant delta equals b squared minus 4ac, so that we can determine whether it's going to be greater than 0, equals 0, or less than 0. If it's greater than 0, means there are two intersection points. So if it's 0, which there's only one intersection point. If it's less than 0, which means there is no intersection point. In other words, it means there is no solutions for the simultaneous equation. So let's look at the book. So for a pair of simultaneous equations that produce a quadratic equation of the form that if their b squared minus 4ac greater than 0, which means there are two real solutions. It could be a greater than 0, so that there are two, or a less than 0, there are still two. So also, there's only one solution. There are two situations here. So if the discriminant less than 0, which means there's no real solutions to possibilities here. So let's look at example 6 together. So it says the line with equation y equals 2x plus 1 meets the curve with equation k times x squared plus 2y plus k minus 2 equals 0. So at exactly one point, give that k is a positive constant. You need to find the value of k. How could we find it? It tells us exactly one point, which we will know delta equals 0. Then we can substitute y into the equation. Then we're going to have kx squared plus 2 times 2x plus 1 plus k minus 2 equals 0. And then we're going to have kx squared plus 4x, then plus k equals 0. There is only one point. So we have delta equals 0. What's delta? Delta is 4 squared 16 minus 4 times k equals 0. So we have k squared equals 4. Then what's going to be? We have k equals 2 answer. One is positive 2, another is negative 2. So let's look at the problem. We have positive 2 or negative 2. However, in the problem saying k is a positive constant, we need to disregard k equals negative 2. So k could only be 2. Let's look at problem B. So for the value of k, find the coordinates of the point of intersection. So we directly take k equals 2 into the equation. So we have final equation 2x squared plus 4x plus 2 equals 0. And we eliminate 2 at both sides. We have x squared plus 2x plus 1 equals 0. And then we substitute this into that, right? So we have x equals negative 1, and then we can substitute x equal 1 into the linear function. We'll get y equals negative 1 also. So we find out the intersection point. The coordinate for the intersection is negative 1, negative 1. All right. So for the exercises 3C, that I wish you guys would stop the video and try to solve them all. If you still don't have the ebook, you could leave a comment and leave your email address. I'm going to send to you, or you can send an email to me. I'm going to send to you. All right. So there are 9, and all the exercises will help you to understand what does this session mean. All right. So for next video, we're going to discuss about linear inequalities. I hope you will enjoy this video and understand how to do simultaneous equations on graph, and also understand the discriminant when it's greater than 0 or equals 0 or less than 0. What does that mean? Okay, so here is the end of the session. See you next time.